I focus on human skeletal remains. Can you hear me okay? Is that better? Do you guys hear me better?
Yeah.
Okay.
No, absolutely.
So I focus on human skeletal remains. Primarily, I've been working at Copan. So what I'm going to be talking to you about today is how we can use human skeletal remains to better understand the Maya. And just a quick note, I'll be showing you a lot of bones in this presentation, and a lot of skulls and other things. Is that better? Just be close. Sorry. And so that you'll see a lot of burials and bones and skulls and that sort of thing. So I don't usually show too many bones in presentations. This isn't a specific context to try to share this with you. I just wanted to make sure that we all understand that these are people. And so I'm only using them for this purpose. Okay? So not to objectify them. So the basic outline for the presentation is what can the human skeleton tell us about the past? And then I'm going to go into what is bioarchaeology, what exactly is this term and what is this field? Also, what are some of the limitations with Maya skeletal samples? There are quite a few that really put limits on what we can say effectively. So what advances in analyses have been made? So this is really why I'm here. I'm going to be talking to you about biogeochemistry. So this is talking about paleo diet and mobility. I'm also going to be talking about biodistance, which is a way we can infer familial relationships. We don't have very much in terms of ancient DNA among the ancient Maya. Those of you who have excavated there probably know why. We have very limited preservation. And then I'll be summarizing the case of Mo and what his body has told us about the ancient Maya, and really what bioarchaeology has done there. And of course, Mo, that is largely attributed to Penn, Bob, Jane Bykster, my advisor, who did the skeletal analysis, Loa, Ellen Bell, who's in here somewhere. So when we're talking about Mo, keep them in mind. So what is bioarchaeology? It's been used to refer to a wide range of data stemming from human skeletal remains. And really what it's concerned with is the cultural and historical framework of understanding human skeletal remains. So examples include the emergence of agriculture. We might have the emergence of and nuances of social complexity, population movements, and other such questions that are more cultural and archaeological than biological in origin. So you're looking at the interplay of culture and biology. And so what exactly is a burial telling us about the past? A burial is the original interment of one or more individuals in a prepared repository. And this might be a grandiose tomb, this might be a very simple pit. But the content of that really can tell us so much about what's going on at a particular site at a particular time. So the burial includes the grave furniture, all of those elements, the artifacts. And we want to know the materials and quantities of those. And the bones give us the basic age and sex. What's going on with that person's health? Can we tell how they died? And then we can tell a little bit about behavior. In terms of behavior, this is where you're getting into where the person's from, their place of origin, who they're related to, and what they were doing during their life, such as body modification and things like that. So in terms of the burial, and it's sort of introducing this to contextualize the skeletons that I will be talking about, because they've all come from an archaeological context like this. A placement of a tomb or a burial really is creating a genealogy of place. It's tying the past to the present, the living to the dead. Okay? Mortuary structures are both visible and invisible structures. You might have large tombs. These are the very visible structures that become part of the everyday life of that community. Whereas we might have more invisible structures, which are tiny house burials. Like, for example, you wouldn't necessarily know this was there from 2 or 3 generations before, but it still has cultural meaning, perhaps, to that residential group. Whereas something with the Hunal tomb, this was venerated and known about for 400 and some years. So our skeletal population, this is something to keep in mind. Where are we getting our samples? What we can see on the landscape, you've seen a lot of the buildings and construction so far. So this is where people were living in the past. We can really see how big these sites were. But what we're actually looking at when we look at skeletal samples is a very small proportion of that. So you have everybody that's dying from that major living population. And then you have your mortality sample. So this is the people who are buried. And they're buried in different ways. So this is affected by culture, such as cremations or internments. And then you have the excavated sample. So this is what we can get permission to excavate. So again, a smaller subset. And then finally, what's actually preserved. And that's what we're getting, this little tiny sample of analysis. So this is something to keep in mind as I'm talking about these larger population ideas for the ancient Mayas, that this is based on a pretty small subset, the best of what we can get. And now preservation. So this is the major challenge working in the Maya area. I think it's one of the great challenges of working in this area, because bioarchaeology has really sort of figured out ways to get around this really bad preservation, and that's what I'm really telling you about today. So these couple examples, we have, this is actually the recently excavated Orapendula tomb. And you can see the before excavation and the after excavation. They don't look particularly different because there wasn't a lot there. The entire burial was crushed. And to give you an idea, this is what the pelvis, and anybody who has ever worked with skeletons, this is the most important diagnostic element in the skeleton in terms of age and sex. This is what it looked like in the actual burial. We removed it in block, trying to get as much as we could. Turns out this was mostly cinnabar and dirt. This is what we recovered. A piece of the acetabulum. This is a piece of the hip joint, and that's it. So it gets pretty adventurous. This burial in particular this is Molly Fuhrer Donaldson from Harvard, who was in charge of excavating this. And we're both about 5'8". And so this gives you an idea of how big this tomb is. Excavating upside down. This is similar, I guess, from the Hunal tomb and how that was excavated. It's kind of adventurous. We actually had to take a rope and swing in, land on the plank in your socks, and then excavate upside down in cinnabar, so you're wearing gloves and a mask. It's very fun. I have some fun tomb stories if you guys want to ask about that later. Being tiny is often kind of a curse sometimes in archaeology. I'm often the first one dipped into the tomb, or dropped in, or, you know. So if you can fit, go ahead and go. Okay. So here's another example of preservation. So this is a more modest burial. So this isn't a grandiose tomb. One would expect perhaps that a tomb of this size, you might have better preservation. And we do have a couple examples of that, markedly Hunal, which I'll talk about later. But when you have the more modest burials, what you actually have, this is the tibia, the shin bone, which is a pretty big, dense bone. And actually what we're coming up with is practically paper here. So you can see I'm excavating it with a dental pick and a brush, and still hardly anything was able to be taken out. So preservation is a huge challenge, which leads me into what we can say when we do find certain skeletal elements. I'll show you a couple examples of some things are preserved pretty well at Copan. There's about 1,300 burials there, and I've been through the entire collection at this point, and I'd say about a third of it is not too bad. You know, you can really do some good analysis. About 2/3 of it, we always have teeth, and then that last third, it sometimes is really poorly preserved, not to mention some of the issues that insects and rodents like to do to burials. Okay. So first I'm going to talk basically about osteology. So this is the actual study of the bones. And I'll run through this pretty quickly. I don't want to give you an osteology class. But this is going to give you an idea of some of the trauma that we can see on the body. Here, this is what is called a perifracture. So this is right in this part of the bone, right in this part of the arm. And this has been interpreted as having a fall or some sort of interpersonal violence. And I mention this because Hunal has a perifracture, and I'll show you his later. This is an example of does anybody have really bad lower back pain? This is a lumbar bird. So this is somebody's lower spine that has been essentially crushed and having some arthritic lipping and things like that, that can tell us that this person was doing a lot of heavy lifting, this is not necessarily the easiest life. And then we have other things of personal violence, cut marks, for example. And then a nice heel depression fracture. This person was hit in the head with something so hard it crushed part of their skull, but they lived through it, so they had just actually a divot. And then finally, this is a nice broken femur. This isn't from Copan, but I put this in here for the reason to show you When you have a broken femur like this that is pretty well healed, think about the context of breaking your leg to this extent. You had people taking care of you. If you were a farmer and you broke your leg like this, and you would have to really depend on your community to support you while you couldn't do the things that you normally would. And teeth are the most important thing for us when we're talking about the ancient Maya, because they almost always preserve. So it's really important I spend most of my time looking at teeth. I have long conversations with my dentist about very odd things. Okay, so tooth loss is a very common thing. We see this as a result of lots of different factors, but if you ever see somebody in their late 90s who have no teeth, this is probably what their skeleton looks like. Then we have dental wear. This tells us how much grit is in the diet. It also tells us how old someone is. And then, of course, we have giant cavities, what we call carious lesions. And these really inform us about the diet. How much, because when you're not brushing your teeth. So if you're having a lot of sweet food in the diet, corn is particularly bad for cavities, but the fact that it's put on groundstone counteracts some of that. High protein diets can sometimes result in cavities like this. Okay. So the next thing is, this is the question that's often asked, and this has been especially pertinent for the ancient Maya in terms of what was happening at the collapse. What can we see in the diet? Were people starting to starve? Was this part of a collapse that we see in terms of the social structure? Was there some sort of factor that was affecting people, marking on their body, that we can see and interpret? How am I in time? Okay. So these are called non-specific stress markers. Basically, we don't know what they're caused by. It could be anemia, it could be parasites. But the real key thing I want to tell you about is the osteological paradox. So the question I want to ask you, does a person without skeletal lesions represent a healthy person or a weak individual who perished at the first exposure of a pathogen? The thing to think about is if you can survive a disease long enough for it to mark your skeleton, you're actually a healthy person. You might have had some disease, but your immune system was strong enough to let you live long enough for it to be marked in this way. Whereas if you die right away, you might not necessarily be a healthy person. So this is something to think about in terms of when we're talking about the collapse and sort of these large-scale interpretations made from a few skeletal lesions. Now I'm going to get into some of the advances. I'm going to start with Paleo diet, and this is based in isotope analysis. So we've done some research on diet prior to a lot of the isotope analysis on ethnohistoric data, iconography, residue analysis, even coprolites. So isotopic analysis can identify carbon and nitrogen from the bone that will tell us the protein and plant resources from which people were deriving their diet. So what were the Maya eating? This is the Maya food web. And this definitely highlights what was available, and you can sort of see a nice cluster right in this area of some of the major Maya sites. So I'm going to walk you through what some of this means. On this side, we have the nitrogen isotope. Here we have carbon. So carbon is telling us what type of plants there were. And there's two types of plants, C3 and C4. Easy way to remember this is C4 is maize. That's why I have it in yellow, right? C3 plants include things like barley, wheat, beans, basically everything other than maize. Then we have nitrogen tells us about the proteins. So we have terrestrial resources and saltwater resources. So the saltwater resources have a much higher nitrogen signature, whereas for carbon, just notice that the most negative is the C3 and the most positive is the C4. Okay? So what you can see here is that, for example, at Altin Ha is in Belize, they have a slightly higher signature of probably saltwater resources, but they were still heavily deriving their diet from corn. Copan, heavily corn, probably terrestrial resources. Okay, this is making sense, right? Sorry, I keep talking on. And this is just giving you a more idea about what C4 and C3 plants look like. And it's all based on their root structure, how they incorporate photosynthesis. They're discriminating against specific isotopes. I won't go into too much. Okay. So what does this actually look like within the skeletal sample? This is an example from Altunha by White et al. In 2001. And what this is essentially showing us here is that they looked at 3 groups. They looked at their entire skeletal sample, and then they looked at specific zones, and then finally at a structure that they thought was a little bit more elite. So when they ran all of this, what they came up with was they found that for the carbon, the males were eating fewer C4 foods. So they were eating less corn, but not in this elite sample. So what's going on here? What they think happened here is that they're actually eating more terrestrial mammals, which are eating that corn. So as it's moving through the food system, they're winding up with more, the males have more C4, but that doesn't mean they're eating more corn. Whereas in this case, it's probably that the males are eating less corn. Same thing with here. We have that the males, and I should mention males are blue, females are red. I'm sure you figured that out. But so same thing for the nitrogen. We're finding that we're having more meat in the male diet. And this is speaking to gendered food behavior, which can tie to, and you'll find gendered food behavior, class food behavior, lots of different things can happen with who's eating what and why. And down here at the bottom for structure C13, what's really interesting is that it looks like this group of people is eating, the males are eating the most amount of seafood resources. So all the males are generally having more protein, but they're having distinctly more seafood. So you're seeing differences even within the same site in terms of who's eating what. And now I'm going to talk about strontium. Strontium is my favorite thing. It's incorporated, so teeth, you're catching on. It's teeth, strontium, and I'll talk about biodistance after that. So that's my dissertation in a nutshell. But strontium is extremely interesting and useful because it's based on the geological signature, the underlying geological signature that's based in the groundwater that gets into the plants, the animals, and eventually humans. What happens is strontium gets integrated into the body through food consumption and water consumption. And the strontium actually replaces for calcium in your bones. So we all know that calcium, we're supposed to drink a lot of milk, right? Trying to grow those healthy bones. But instead what's happening is strontium gets put in. So once strontium is put into your body, into your teeth, that never changes. That signature doesn't change. So it's going to tell us exactly where you were living when you drank or ate that food that contained that strontium resource. So once you analyze the dental enamel, what you find out is where somebody lived. And there's been huge amounts of work done by, notably University of Wisconsin, Madison, Hodel did a bunch of baseline data, which is what you see in this figure on the right. And what's really kind of cool about this is that Copan has its own nice signature. And so this is helpful for me when I'm trying to differentiate between different groups. And you'll notice that each of these values, I hope you can see this from the back, but values are, like for Copan, for example, it's 0.7071 to 0.7082. This is a very small range of values. It doesn't sound very statistically significant, but these very small changes matter a lot. So what you can see is that this is a whole geological zone that differentiates between the Maya Mountains, for example, the Penn, okay, central Guatemala, especially the Yucatan Peninsula as well. Kaminau-Huyu has a whole different signature as well. So what we can really look at is we can take these strontium values and map migration patterns among the ancient Maya using simply dental enamel. The one caveat with this is that when your teeth are developing, you're very young. This is from term of gestation to about 12 years of age. So when we're doing strontium analysis of teeth, we can tell childhood. We can tell maybe where you were born, where you lived to maybe 3 or 4 years of age, and then we can look at the second molar, and that'll tell us maybe 4 to 7 years of age. And when we look at that third molar, your wisdom tooth, that's going to tell us 8 to maybe 12 years of age. So it's pretty easily done. What we have to do is this is a little tiny drill, very much like what you would have at the dentist. And instead of tossing away the powder, as your dentist does, we save it and analyze it. So we take about 5 milligrams of dental enamel, which is a very small amount. And we have to clean it through a bunch of different processes. And eventually we put it on the mass spectrometer. And this will tell us the exact concentration of strontium 87 and strontium 86. And it's this ratio that gives us that underlying value that matches to that geological map that I showed you. And it's pretty cost effective too. This is being employed a lot more because it's somewhere between $40 to $80 a sample, which is not bad when we're talking about archaeological costs, right? So how has this been applied? I did a pilot study at Copan a couple years ago on a sample that was from excavated by Tulane University in the early 90s. This is group 1002. This is the group that's directly south of the Copan Acropolis. So here's a closer view, and what I just want to show you quickly is that each of the different colors is a different time period. Most of the sample came from the Aquaquinera phase. So a total of 52 skeletons were excavated from this site, at this part of the site, but 14 were included for analysis. We have different ages, different sexes, and different social strata as far as what we can infer from the burial. And trying to kind of get a nice survey of what's going on here. What we found, the blue is the human individuals from group 1002. Green is some faunal samples I took to see if we have a baseline for Copan still. And what we have is we have 3 individuals who are not from Copan, buried at group 1002. So that's 20% of the sample that's from somewhere else. And Carolyn Freewald from University of Wisconsin-Madison is doing strontium isotope analysis all over the Maya area, and she's finding about a 25% migration rate. So this is picking up on first-generation migrants, and she's finding this across different time periods as well. So there's something very interesting going on in terms of why we're having this constant 25% migration rate. I mean, this is before planes, trains, and automobiles. So one of the examples that is from somewhere else, this is a 35 to 50-year-old male, and he was buried pretty centrally in structure 33 right off Courtyard A. There's some evidence that says he might be a sacrificial burial, but sacrificial burials are very hard to definitely say, yes, this is a sacrifice. So he was from around AD 600 to 650 is when he was buried, but he comes all the way from the Penn. And some people have thought that perhaps what we're seeing is these immigrants are actually spouses marrying in, or something like that. Slaves, captives, that sort of thing. When we have a 25% immigration rate with both sexes, both ages, different social strata, it doesn't look like all of those things that we are predicting are necessarily working. So there might be something else going on. This is the prelude to my research, I guess. So I've sort of gone over this already, but this is really speaking to the dynamic urban environment. Copan was a very big urban center, and I suspect that if we do this at Tikal in sort of a systematic way at some of these other major sites, we're going to find a sort of dynamic urban environment. I think of it as perhaps like a Little Italy scenario. So there's another way to infer mobility, and this is with oxygen isotopes. This is particularly interesting because it can tell you the last portion of somebody's life. Because this is integrated into the bone, and your bone is constantly changing and remodeling. This is how if you break a bone, it can heal, essentially. So this is what oxygen can tell you. It's a little bit more problematic because it's based on rainfall, which is, as we know, very seasonal. You might have El Nino events and other such situations. It's also based on elevation and latitude. So Doug Price has done a bunch of this as well from University of Wisconsin. If you're interested in, Doug Price has done a ton of this. So if you're interested in more isotope, I can give you 25 references. So this is telling us what water sources were taken into the body. So if it's in the enamel, that tells us about childhood. If it's in the bone, that tells us about later in life. So what you can do is you can combine strontium and oxygen, and you'll get the strontium that tells you about the beginning of life, and the oxygen might tell you, so for example, somebody might be born in Tikal, and you'll see that in the enamel, but they're buried in Copan. And they might have lived in Copan for the last 10 years of their life. So moving beyond isotopes, this is talking about really how we can infer relationships between people at the household level, at the quote-unquote house level, or these large neighborhood structures. Are these large kinship groups? How can we tell this since we cannot really get DNA? Ancient DNA has had some success, but it identifies the haplogroup, which is of limited utility when it's telling us that, yes, indeed, they are Central American, Native Americans. kind of figured that out already. So, biodistance has been sort of really recently employed a lot more, and what this is doing, again, back to the teeth, using dental metric and morphological data, you're able to look at the shape and measurements of teeth across an entire population, and then use a bunch of statistical analysis to infer these relationships, because teeth are a less plastic trait. This means it's much slower to change in terms of evolutionary structure. So your teeth are more similar to your parents and your siblings than to the person sitting next to you, unless you're next to your sibling at the moment. Okay, so what you can really do is you can start to track this for family groups, and you can catch several generations of people living possibly within the same household at an ancient Maya site. And so it's mostly done on teeth, but it can also be done on the skull. And I include this because it is a very popular method. It's a little bit of limited utility for the ancient Maya because we have so much cranial modification, which is just ubiquitous. But this gives you an idea. There's hundreds of measurements you can measure all day using sliding calipers, which are a pain. And then you also have morphological traits. Like I was saying with the teeth, you have the metrics and the morphology. So what you have is that you have different morphological variants. This is just called the Inca bone, for example. So what does this look like? The results basically summarize that you have statistically significant values, which just means that for these teeth, the people in this one particular household are more closely related to each other than to anybody else in the site. So it's tractable in that way. All right. I'm going to talk a bit about body modification because everybody likes it and it's kind of a sexy topic. But I don't want to, it's not necessarily a new advance in terms of analysis. But I just wanted to walk you through a couple things. We're thinking more and more that it's related to identity. Possibly how people are choosing to identify themselves based on profession. It could be related to social status. It could be related to your group affiliation. Again, we're not quite sure, but this is something that's been in the works. Vera Tiesler is now suggesting that perhaps it's imitation of some of the gods, certain glyphs, and other such patterns that are being put onto the teeth, which I think would be very interesting. So there's a lot of different patterns. I won't go into too many here, but this is just a couple examples. A triple jade inlay. And this is done before the days of drills. So this was practiced up until the 1960s in Africa. And it's actually, there's a few examples, especially from Sudan, that it's still occurring. But this was done with chipping and filing, so you can imagine how intensive a process this was. So also this suggestion has been that this is sort of a bloodletting type of ritual for the ancient Maya as well, because this would have been a painful process. Instead of piercing your tongue, you might be carving your teeth. And what's interesting here is for the Kauki tribe and the Mubunza and Pongali tribes in Africa, they're specifically tied to tribal affiliation. This person has one parent from each tribe, so they have the combination type. Both parents are from the same tribe, single type. So without this person even having to say a single word, you can tell their affiliation. And then, of course, cranial modification. If you've studied the Maya at all, you know what this looks like. It's done with pads on the front and the back of the skull, resulting in a form similar to this. And this happens to be my favorite skull at Copan. It's operation 42-5, about a 40-year-old woman buried in a very nice tomb context. But her skull is almost heart-shaped. So some people think this looks very strange, but this was aesthetically perfect. She would have probably been quite the looker in her day. Okay, now as I mentioned, let me make sure I don't forget anything in my notes. I think I'm going a little bit long, sorry guys. Okay. So Yash Kukmo, this sort of famous man from Copan. What we do know is that it was about the 5th century in the early classic period when this new king arrived to Copan. And he became the celebrated founder of the Copan dynasty. We've seen him on Altar Q, we've seen him in multiple different cases, and he's often shown with these Talak goggles, this Teotihuacan affiliation. So this has been, his place of origin has always been in question, especially after he came from the origin house. Where is the origin house? Right? So the Talak goggles have made people think perhaps it is this Teotihuacan connection. And it's persisted all the way until, as we know, Alter Q with Hitchcock. I see why people aren't using notes. Okay. So the Hunal tomb, so this was excavated by Bob and Loa and Ellen Bell, and the skeletal analysis was done by Jane Dykstra. So I'm sort of presenting the results on their behalf. But the Hunal tomb, this gives you an example. This shows you exactly what it looked like inside the tomb. And then we have some of the vessels. I believe this one's from Tikal, and of course his skull. This was a beautifully painted red burial. This is the most red skeleton I've ever seen. And it is just in a completely rich context. So, let's see. It's up there. The cost of being king. So how did Yashkugmo get here? So I'll talk a little bit about his origins in a minute. But what we have, the cost of being king was coined by Jane Dykstra, probably, I think it was 2000 at UCLA presentation. The cost of being king for Hunal, he had a lot of injuries on his skeleton. He did not have a nice, people weren't so nice to him perhaps, or he was very, very clumsy. I don't think he's particularly clumsy, but I think there was a lot of things going on. What we have is that perifracture that I told you about earlier. So there's a chance that this happened from a fall, but more likely it was parrying. And as you'll, let me go back to Alter Q for a second. What's important about this perifracture, it's on his right arm. Notice the shield on his right arm on Alter Q. This has been suggested perhaps this has something to do with this unhealed fracture that he has. So let me go back to this. Because what happened is after his arm was broken, one of the bones healed and the other did not. So you can see it better down here. This was actually, it's called pseudoarthrosis, so he had a false joint. It was movable. This would have been extremely uncomfortable. Then he also had the sternum, so the bone right in the center of your chest. This was crushed and thinned. And then we have a broken shoulder, a depression fracture in the skull. See, now all the osteology is coming together. And this is a broken shoulder. And then he had several broken ribs. This is the type of injury pattern you would see if somebody was in a high-velocity car accident. Okay, so what else could it possibly be? There's been a couple suggestions. Perhaps he was doing a ball game and hit with one of those 8-kilogram balls that was made of rubber, crushing his chest to some extent. The shoulder might have been a fall or some sort of event like this. The depression fracture, certainly somebody hit him in the head. And he has a few other minor fractures throughout the skeleton. Okay. And now, in terms of his origins, like I said, we were concerned with where he was from originally. Was it Teotihuacan? I mean, that's a pretty long way to travel. We have some of the images there that would suggest this, but I think it's more about the myth than the actuality. So in 2000, let's see, when the first analysis was done to see if it was between Teotihuacan and Copan, what was going on there? And there was some sort of evidence there was an original signature, I believe in 2004, that said he was probably from Tikal. This has recently been redone in a 2010 publication by Price et al., and some of the et al. Is in the room right now. And what this has done is it actually refined this, saying that he was more likely from the Maya Mountains, perhaps near the site of Caracol. So this was his birthplace. Then what happened, there was likely some fostering that happened in Tikal, because his early teeth show this Caracol signature, and his later developing teeth show this more Tikal signature. And then he winds up in Copan, of course. So there's something very interesting happening with his life history. He began in one place, was fostered likely in another, and then finally wound up as the king at Copan with all of his injuries. So tying all of this together, really, when you incorporate bioarchaeology with the ancient Maya methods of archaeology, or the basic archaeological analysis and the maps and everything else, what you get is this conjunctive approach that really ties all of this together to tell us about the specific life history. We couldn't know any of these things without the other things, so everybody's contributing major components to this. But what we do know, just from all of these data put together, is that Yashkugmo was about 7 years of age when he died. He He came from somewhere else. He had sort of a violent life, as far as we could tell, but still was institutionalized as this prominent and key figure among the ancient Maya Copan.